All right, this is the review for preparing for the quiz. That's sections 1.5 to 1.8. I'm hoping that you will go through this video and then be able to go back and review it again and kind of practice a little bit, and that way it'll help you to become really successful on this quiz. I want you to do a good job. So on the first one, it says name the vertical angles. So definition of vertical angles is opposite rays that intersect, or we just say that there's two lines that end up intersecting. And so I always called it the kissing fish, which is right here. And so the vertical angles is angle 4 and angle 2, and by rule that those vertical angles are congruent. Name supplementary angles. So the definition of supplementary is where you have angles that you add together to equal 180 degrees. So, excuse me. So the supplementary angles that you can look at is as long as you see like a linear pair. So here's this straight angle, and we don't name the straight angle. We see the two angles that we have, 4 and 3. Those are the two angles that if you were to add those together, they equal 180 degrees. So let's write that out. Angle 4 plus angle 3 equals 180 degrees. There are possibly another set here if you happen to see it. So if we were to see a straight angle this way, and here's the two angles, so we've got these two angles. So then we would say that angle 2 and angle 3 also equals 180 degrees. On this one, we've got two different problems here. We're looking at the first one where the measure of angle PRV equals 3x plus 45 and the measure of angle DRV equals x plus 15. And we need to figure out what angle is PRV and DRV. If we were to look at this, we could see that we have a straight angle this way, and this ray is splitting it into two angles, so those angles are supplementary with each other. And so that means that we have to add those angles together and set them equal to 180 degrees. So let's go ahead and let's do that. So 3x plus 45 plus x plus 15 equals 180 degrees. We combine our like terms. 3x plus x is 4x, and 45 plus 15 is another thing that we can combine, and it ends up equaling 60. So we got 4x plus 60 equals 180. So that's combining like terms. We continue to solve. This goes away. That's what we want. 4x equals 120. Undo the multiplication by dividing. And so x equals 30. Now, one thing to be very careful is that we've got to read the problem and make sure that we've answered the question. And we're not done. We've only figured out what the x value is. So let's go ahead and figure out what angle PRV is. So angle PRV is 3x plus 45. And since x equals 30, that's what I'm going to substitute. So then we have 90 plus 45, which equals 135. So angle PRV equals 135. We can go ahead and figure out what the other angle is by going ahead and plugging it in. But one thing that we got to be able to recognize is that if we go ahead and subtract 180 from 135, then we should have 45, I believe. So let's see, 5. So that should be 45 degrees. Well, if we check this, where we have angle DRV, it's x plus 15, and x equals 30, so we add 30 plus 15. So we're going to find out that angle DRV does indeed equal 45 degrees. I need to put degrees there as well. On the next one, the measure of LKC equals 3x plus 10. The measure of angle CKD equals 5x plus 48. So we need to find the measure of angle LKC and the measure of CKD. Well, if you look here, we have this right angle, and so the two angles, if we were to add those together, they are complementary. So we add those angles together and set them equal to 90 degrees. So let's go ahead and let's do that. So we have 5x plus 48 plus 3x plus 10 equals 90 degrees. Combine like terms. Now, the way to tell that we combine like terms is that we have the variables on the same side of the equal sign. We do not subtract 3x on the same side of the equal sign. So this becomes 8x. We can still combine the 48 and the 10, and so we have plus 58 equals 90. Subtract 58. This goes away. That's what we want. We have that 8x equals 32. We've got to undo our multiplication by dividing, and we have that x equals 4. And so we've got to be very careful in answering the questions. We got to figure out what angle LKC is. So if angle LKC equals 3x plus 10, then I would substitute 4 for x, so it's 12 plus 10, which equals 22. So that is what the measure of angle LKC is. Now let's look at the other measure, which is CKD. So angle CKD equals 5x plus 48. Now you can go ahead and subtract 90 from it, and should still be okay. 5x plus 48. All right, so x equals 4. Plus 48 equals 68. So angle CKD is 68 degrees, and let's make sure that it makes sense. Is this a true statement? Is 22 plus 68 equals 90 degrees? Yes, it is. So that's a good way to go ahead and check to make sure you're on the right track. In the diagram, GH bisects angle FGC. Key word right there, bisect. We're going to solve for x and then find the measure of FGH, find the measure of angle HGI, and find the measure of FGI. So since we have that GH bisects, you notice that whenever you hear the word bisect, it is splitting something in half. It could be a segment, And it could be an angle like this one in this case. So see the tick marks right here? So it's saying that those angles are congruent. So if those angles are congruent, then we have to set those equal to each other. So let's go ahead and let's do that. So we have, trying to figure out where to work. I think I'll work right here. So I've got 4x minus 14 equals 3x minus 3. Okay, so now we've got an equal sign that's in between. So we've got to get the variables on the same side. So we have to undo the 3x. Now, when we tend to do this, I typically see students forgetting to put the variable, tacking the variable where I only see minus 3 on both sides. You can't do that, and that can create some errors. So let's get rid of those bad habits. Include those variables. 4x minus 3x equals 1x, or we can just say x. So x minus 14 equals negative 3. We add 14 on both sides. This goes away, that's what we want. And we have negative 3 plus 14 equals positive 11. So now we figured out what our x value is, because that's what it was asking for. Now it wants us to find the measure of angle, let's see, FGH. So FGH, angle FGH, and that is 3x minus 3. 3 times 11, since that's what we figured out what x is. 33 minus 3, which equals 30. So that's saying that the measure of angle FGH right here is 30 degrees. And since GH is bisecting this angle, this should be 30 degrees as well. Well, let's check to make sure that that's what it is. So HGI, so angle HGI, and I'm going to go ahead and write the expression of 4x minus 14, where x equals 11. So 44 minus 14 does indeed equal 30. So we have that angle FGH equals 30 degrees. We have, that one. Let's see, the measure of HGI is also 30 degrees as well. Well, it also says to find the measure of FGI. So that's the whole angle. So you're using the angle addition postulate. So if we were to figure that one out, so the measure of angle FGI, it's just adding both of these together. So the measure of FGI is 60 degrees. On this section, need to make sure that you know how to construct with a compass and a straight edge, knowing how to construct the congruent segments, congruent angles, perpendicular bisectors, and angle bisectors, because we're going to see some questions on the quiz about that. And I did put a question on here, so we're going to be looking at it in a little bit. So if you need to go over it again, I did email you the links, and so just go ahead and just go through those links and try to practice them and make sure that you know how to do the steps, because you don't necessarily construct, but you need to know what the steps are. Okay, this one is find all the angle measures. So we have here, we need to understand what we can assume. And so on this one, we would see, first of all, the vertical angles. I always like looking at the vertical angles. The kissing fish. All right, so we know that those angles are congruent. We also know that this angle right here is perpendicular, and since we have a linear pair, then we know that 60 degrees is a complementary angle to angle DOC. And since it's complementary, then this is going to be 30 degrees. So then we would know that angle DOC is 30 degrees. And since it's congruent, we know that this is 30 degrees. Okay? And since we have vertical angles right here at AOD and BOC, those are also vertical angles. And if we look at 60 plus 90 degrees, so what I'm doing is I'm adding these angles together because that's what's making the vertical here. So my kissing fish is going this way now. And so 60 plus 90 is 150. So I know that this is 150 right here if I add those together. So BOC is 150 degrees as well. On this one, find the value of X in all the angle measures. So we have these two lines, and here it's forming vertical angles, and vertical angles are congruent. So we have to put these two expressions equal to each other. So 3x minus 40 equals 2x minus 10. So we get variables on the same side by subtracting 2x. This goes away, that's what we want. 3x minus 2x is 1x, or we can just call it just x. So it's x minus 40 equals negative 10. We undo the subtraction by adding. This goes away, that's what we want. And we have that x equals 30. So now we figured out the x value. And so the next thing that we have to do is figure out what angle AED is. Which is 3x minus 40. We said that x equals 30, so that's what we're going to substitute, which is 90 minus 40, and 90 minus 40 is 50. So now we know that angle AED is 50 degrees. Since we have vertical angles right here, then we know that BEC is also 50 degrees. And if we were to go ahead and plug in 30 right here, then 2 times 30 is 60, and 60 minus 10 is 50. So you can always double check to make sure that that's correct. Okay, I want to clean this up so that you guys can see this a little bit. So what we had figured out here is that we know that this angle here is 50 degrees. And since that's 50 degrees, it's forming a linear pair right here. So we would take 180 and subtract 50 to get 130 degrees. So this angle right here is 130 degrees. So that's angle DEC. So angle DEC is 130. And if you look, we have our vertical this way as well. See the kissing fish this way? So that's congruent. So if this DEC is 130, then angle AEB is also 130 degrees. On this one, it's asking which illustration shows the markings for the construction of the perpendicular bisector. So for XY, well, first of all, that's one of the things that we've got to look at whenever you had constructed perpendicular bisectors. And so we talked about this a little bit in class. So the perpendicular bisector ends up being this one right here because of how the tick marks are set up. On the first one, on this one right here, all you had to do was figure out your tick marks on this way, and then be able to put your compass point here, and then draw your arcs this way on each side here. And so that ends up being just a perpendicular line, not a perpendicular bisector. So that you can see those tick marks. On this next one, on the third one, that is an angle bisector where you needed to take your compass and draw your angle right here, and then you put your compass point here and then make an arc here. Put your compass point here at the intersection and make the other arc, and then it ends up being a angle bisector. On the fourth one, I don't know what it is. I think it's probably, looks like you're getting ready to draw parallel lines, and we'll be looking at that later on, so we haven't even gone over that. But just remember what a perpendicular bisector looks like. All right, on this one, it says that if TU is a mid-segment, so in other words, if they're saying that this line is a mid-segment of triangle QRS, it's saying that the length of these are congruent. So RU is congruent to US. And also on the other side as well, but I'm more concerned about the line RS, because it's asking what are the coordinates at point U. And so if it's saying that it's a mid-segment, then U happens to be the midpoint of RS. And just remember how we would find midpoint. So this is our midpoint formula. And so it's asking what are the coordinates of point U. So we have got to figure out a coordinate point of U, which is the midpoint of RS. And we're going to use this formula. And sometimes whenever it has letters, it kind of messes us up. But I'm hoping that you guys can be able to see this. All right. So if we add the x's, all right, we add the x's. So here's my x value here and here. So we're going to go 0 plus n divided by 2. And now we're going to go ahead and look at our y's. And so here's our y value, which is right here and here. So now we're going to have m plus 0 divided by 2. And then we have to keep that to where it looks like a coordinate point. So 0 plus n is n. So we have n over 2. M plus 0 is m. And this is our midpoint. So that's all you would have to do on this one. Okay, on this one we need to find area of a triangle. So we have that area equals 1/2 times base times height. Just remember that the height has to be perpendicular to the base. So another way to write this is base times height divided by 2. These are both equivalent. And if we were to look at the triangle, the base ends up being 14 and the height is 12.1 because the height is perpendicular to the base. Here's the base, here's the height. All right? So now let's go ahead and let's put it into our formula. Area equals base, which is 14, times height, which is 12.1, divided by 2. And if we go ahead and put this into the calculator, it's 14 times 12.1, and then we take that answer and we divide it by 2, and we get 84.7. And since we're talking about area is measured by square units. In this case, it's meters squared. Okay, so we want to find area and perimeter of this irregular shape. It looks like the free throw line in basketball. And so we're wanting to find out the area. So what we have to do is we've got 2 different spaces, and we've got to figure out the area of each. And so the formulas that we're going to be using is the area of a circle, area of a semicircle, and area of a rectangle. Now, so you notice that the semicircle is half a circle. So that's the reason why that we have area equals pi r squared divided by 2. We know that the area of the whole circle is pi r squared, but now we just need to divide it by 2. And if we were to look at this semicircle, we've got to be able to find out the radius. And the rule is that in order to figure out the length of the radius, it's going to be half the diameter. We are given that the diameter is 4. So the radius ends up being 2. So we'll write this down, that the radius equals 2. And so let's go ahead and find the area of the semicircle. So this is the semicircle. Just remember that when we figure out the area of each of these 2 parts, then we add them together. So that's our goal. So the area of the semicircle, we're going to use this pi r squared, and we've got to divide it by 2. So then we have pi times 2 squared divided by 2. If we want to keep this in the convention, 2 squared is 4, so I'm going to write it as 4 pi instead of pi 4. And then we would treat it as if it was like pi is a variable, which it is not. Pi is actually a number. So we just take this part right here, 4 divided by 2, which is 2, so we end up with 2 pi. So the area of this semicircle here is 2 pi. The area of the rectangle is base times height, or it is going to be length times width. And so all you're having to figure out is the length of two different lengths here. So it's already telling us that this length is 4 and this length is 4. And so the area of a rectangle is base times height. Well, my base equals 4, and my height equals 4 as well. And so it's 4 times 4, which equals 16. So this area here is 16. And once we figure out those areas, then we figure out the area of the whole. Let's go ahead and let's put up here. We said that the area of the semicircle is 2 pi. The area of the rectangle is 16. Now the total area is where you have to add those areas together. So we take 2 pi plus 16, and if you put that into the calculator, it's going to be approximately 22 point, I just going to go ahead and go 3 decimal places. So it's 22.283, and just remember that area is in square units, so this would be units squared. So now we're going to figure out perimeter. One thing to remember about circumference and perimeter, they basically mean the same thing. So if I'm trying to figure out the circumference of a circle, I am going along the edge of the circle. It's like you're making a circular fence. That is circumference, which is also perimeter. And so to be able to find the circumference of the circle, it's 2 pi r, or it's going to be pi times diameter. Just remember that diameter is twice the radius. And so I'm going to use the pi times diameter because that's what we're given already right here. We know that the diameter is going to be 4. All right? But we have to figure out the circumference of the semicircle. So the only thing that we're interested in is finding out just this edge. It's like we're putting a fence just right here, and that's it. And that's how we figure out the circumference. Well, it's half a circle, so we have to divide it by 2. So that's what we have here. So let's go ahead and look at finding the circumference of the circle here. So it would be pi times diameter. Well, diameter is 4, okay, and then divided by 2. Well, again, we have the 4 divided by 2, which is 2, so this would equal 2 pi. So it's saying that this distance all around here is 2 pi. That's the circumference. Now let's look at the perimeter of the rectangle. The perimeter of the rectangle, let me use a different color so that we can see this. The perimeter of the rectangle is just going along the edge here. But we've got, typically we would end up using the 2 times the length plus 2 times the width. But in this case, we're just trying to find the perimeter of this area here. All right, so we know that this length is 4, and if this length is 4, then that means that this is 4, and since this is 4, then this is 4 as well. So to be able to find the perimeter of this rectangle, even though we want to say that it's 2 times the base plus 2 times the height, this is just adding sides. That's basically what you're doing. So to find the perimeter just along the edge here, it's going to be 4 plus 4 plus 4, because I've got it bolded that that's the only area that we're interested in. Also remember that 4 plus 4 plus 4 is the same as 3 times 4. So the perimeter is going to be 12. So in order to figure the perimeter here, we've got to be able to just add those. And so since the semicircle is 2 pi, this would end up being 2 pi plus 12. And if we were to go ahead and put that into the calculator, then it's going to be approximately 18.283. So in other words, we took 2 pi plus 4 plus 4 plus 4, and we got our perimeter to be approximately 18.3 if I was to round it to the nearest tenth. If we were to measure perimeter, remember it is a fence, it's like a fence. So it is only one dimensional. So it's not square units, it's just units. All right, area is square units and perimeter is just units.